Yes, hi everyone. My name is Keegan. I'm a PhD student at Carnegie Mellon University, and today I'll be talking to you about some ongoing work we have on marketplace design for LLM-based sales. Yeah, I should mention this is joint work with Leqi, who's finishing up her postdoc at Princeton and just starting as faculty at UT Austin, as well as Emma, who's faculty at Cornell, but is moving to Berkeley soon. And yeah, I should say again, this is ongoing work, so your comments are definitely appreciated. And so we're broadly interested in asking and answering three related questions. The first one is exactly how do large language models persuade in sales domains? What techniques do they use? Is whatever they end up doing good or bad for the end user? And if it's bad, if it hurts the user, then what can we do about this? But first, I want to back up a bit and talk about large language models and persuasion. And so there's been a fair bit of work at the intersection of computer science and psychology over the last year or so, which shows that large language models are able to persuade either at or above the level of humans across a wide variety of domains. And so maybe one thing which some of the computer scientists in the room may have seen is the blog post by Anthropic, where they measured the persuasiveness of their different models over the course of 28 topics. The way they did this was they took human-generated arguments and LLM-generated arguments and showed these to different humans in a study. They then asked humans to rate their views on the topic they're being persuaded of, both before and after they were shown the message, and they measured the delta. And I guess here they're plotting the delta for each of their models. And as you can see that as the model size grows, then roughly the models are becoming more persuasive, even approaching that of a human. Another interesting work in this area is looking at LLM's ability to generate, propaganda. So this is by Goldstein et al., where they compared the persuasiveness of real-world English language covert propaganda, which was found on social media websites, with GPT-3, which was prompted to generate such propaganda. And again, they showed this to a survey this time of 8,000 US respondents. And again, they found that, while the original propaganda is slightly more persuasive, here GPT-3 was doing pretty well, at least according to this study. And maybe a final piece of related work to highlight is LLM's ability to personalize. And so this paper by Matz et al. Studied what I call persuasion at scale, where they took ChatGPT and used it to generate personalized persuasive messages across a wide variety of domains. And perhaps unsurprisingly, they found that these personalized messages were more persuasive in a human study than the sort of generic ones. And they found that this held across different persuasion domains, as well as things like personality traits and even political ideologies. But this is just sort of the tip of the iceberg. Other work in this area has studied LLM's abilities in negotiation tasks, how good they are at designing pro-vaccination messages, climate change awareness messages, and similar to the previous slide, how good they are at political micro-targeting. But the domain that we're interested in here is sales. And so, as I'm sure all of you know, retail sales is a massive industry, $7 billion industry in the US. And a large portion of these are e-commerce sales. But even more broadly, many sales which happen in the physical world have some sort of online component. So you can think about things like car sales. I might want to check out the cars online before I go to the dealership. And you can tell a similar story with things like electronics or clothing. And perhaps unsurprisingly, over the last year or so, we've seen a rise in these AI-powered sales tools. And so, there are kind of catchy headlines or sort of bad publicity around people sort of tricking or prompt engineering these chatbots to do things like selling them a car for $1. But there's been a lot of legitimate work in this area from the business side. So some of you may be aware of this Microsoft Copilot for Sales, which is a broad suite of Gen AI products designed around the sales pipeline. There's also like startups, which from my understanding are essentially like GPT wrappers, which are like sales chatbots designed for a particular domain. So this one here is like automotive sales. And there are also several like open source packages online as well, which are, customizing these Gen AI agents specifically to various sales domains. And so, again, I guess we're back to my first question, which is, we can reasonably conclude that, these things are fairly persuasive and are being used in sales domains. And so you could ask, well, how are they doing it? But in order to ask how they're doing it, you need to ask, well, like how could they be doing it? And so you can imagine a couple scenarios. The first is one in which a system designer deploys an LLM chatbot, say on their website. This is a chatbot which the user can interact with and ask, questions about their products. And the system designer specifies maybe using something like the system prompt, specifies the chatbot to, like persuade the user to buy my car when they ask you a question. And then the chatbot goes to the user, and the chatbot tells the user various facts about why this car is high quality, why the user should buy the car. So these are the things like it has good gas mileage or resale value, things like that. You could also imagine an alternative world in which, again, the system designer deploys an LLM chatbot, again, specifies in the system prompt to persuade the user to purchase my vehicle. And then the LLM chatbot says things like, oh, this celebrity loves this car is a status symbol, things like that. And, this is, I guess, one, not specific to large language models, and two, this is something that psychologists have thought about a lot, actually, over the last like 40 or so odd years. And this is formalized by what's called the elaboration likelihood model. And so this is a popular model of persuasion from psychology, in which is posited that there are two main routes which someone can take to persuade someone else of something. The first is called the central route, which is based on facts and logic. So this is, I guess, what I was showing you 2 slides ago, where I'm revealing facts about the car I want you to buy. And the other is called the peripheral route, which relies on associations with positive peripheral cues. And these peripheral cues can be things such as appeals to emotion or celebrity endorsement, things like that. And so, we wanted to answer, which route do large language models take? And the way we tested this was by deploying LLMs as agents in sort of simulated sales domains. We did this with 3 different chatbots, GPT-4, Claude 3, and Gemini. And the way we did this was by specifying a sort of sales scenario in the system prompt, and then specifying a user prompt in the, in the user prompt. And we varied several things. And in particular, we tried several different scenarios. The base prompt starts by telling the user that, telling the LLM that they're a sales chatbot. I guess we vary what they're selling. So we have like a sort of a high stakes sales scenario, which is a car, as well as a low stakes sales scenario. This is some like magazine subscription. And then what's interesting is that these sort of central and peripheral routes are so well known that even the LLMs know them quite well, and you can actually prompt them explicitly to persuade using one of these methods. And so we did that, and we also prompted them to persuade, using whatever technique they wanted. And then we also varied the user that the LLM was trying to persuade. So here we're trying to differentiate across things like wealth and maybe like social status, things like that. And then it ends with the user asking the LLM, what do you recommend I should do? And the way we evaluated this is we took the messages which were generated using the default prompt, and we compared them to the messages which were generated using the prompt in which the LLM was explicitly prompted to persuade via the central or peripheral route. And we looked at the similarities and differences between them. And in particular, we did this 4 ways. So the first way is the simplest, is the eye test, where We look at, say, the default message and we measure, like what parts of this message are sort of fact and logic based and what parts are appeals to emotion, let's say. But then we have a couple other more quantitative measures. So we also compared the similarity between messages using Rugg and Blue scores, which are sort of classical techniques for identifying similarities in text from natural language processing. These measure things like common n-grams across two pieces of generated text. And then we also took the messages and we embedded them in some high dimensional embedding space and measured cosine similarity between them in this space. And so again, here's like one example. This is the chatbot trying to persuade a user to buy a car. And this is a subset of the response. And if you take a look, it's mostly factual based. So here we highlight statements in green, which are again more fact based, and statements in red, which are more sort of emotional or like peripheral based. And like the message is largely factual, right? It's saying things like, oh, this type of car provides additional space, which could help you carry heavy equipment. We also have good customer service, things like that. And so here are some of the more quantitative results. Oh, and I guess I should say everything here is for GPT-4, but our results for the other two LLMs were pretty much analogous. And so here we have the different scores across different scenarios. The exact numerical value of these scores perhaps isn't so important, but I guess higher is better. And so if you look across the rows, you'll see that in almost all scenarios, default is more similar to central than peripheral. And again, this holds across both scores and scenarios. And our thought process is that, while one of these scores may only be slightly informative, when you put all of them together, it sort of paints a bigger picture, which, coupled with the eye test, at least convinced us that these things are, usually persuading using some sort of facts. Okay, and so that was sort of the first question we were interested in. The second question is, well, is this good or bad for the end user? And your first thought might be, well, this is good for the user because it's not lying to them or it's not using sort of like manipulative emotion-based tactics. But then you think about it, and the example I was showing you on the previous slide was GPT-4 making some compelling fact-based argument for a 25-year-old construction worker to purchase a brand new Mercedes-Benz, which might not be the best. And so what it's really doing here is lying by omission, right? Like there are crucial pieces of information which it is not telling you, even though it's revealing facts. In particular, these are things like, well, there are better cars to drive on a construction site that you can buy for cheaper, as well as, your salary is too low to afford a luxury vehicle right now. And so, I guess I'm not saying that this type of persuasion is bad all the time, but there's potential for negative impacts on the user welfare. Okay, and so like, if it is bad, then well, what can we do about this? And the perspective that we took was from a centralized marketplace designer. So this is a scenario in which there are multiple buyers and sellers, or even just one seller interacting with a bunch of users on a platform, but in particular, this is a centralized platform with some designers, such as Amazon or Facebook Marketplace or AliExpress or something like this. And the question we're interested in answering here is, how can this marketplace designer ensure that these LLM-based sales are happening in a way which is at least not misleading to the marketplace users? And so our idea here is to have the marketplace designer use another LLM to quote unquote fact check responses by the seller to the user queries. So you can imagine a situation in which the user asks the seller chatbot some question, the seller then replies, and then the marketplace sees both the user's query and the seller's response, and then adds their own reply. And this actually works, which is good. So here is GPT-4's reply to the interaction I showed you a few slides ago, which basically says like, yeah, like Mercedes is a great vehicle, but there are a couple of things you may want to consider, such as the price and insurance costs, things like that. And so, you can think of this actually as a game between a seller and a platform, where I guess, and also the user, where the game starts by the user asking some query to seller LLM. The seller has some set of facts that they know. They may choose to reveal some to the user. The platform also knows some facts, which is generally going to be a subset of the facts known by the seller. And this is because you would expect the seller to know more about their product than the platform would. And you can think about the strategies of both players here as the system prompt that they specify to their large language model. So you could say something like, be strategic with this set of facts, but always truthfully reveal all the facts you know about such and such. And so, thinking about this more as a game, you can formalize the protocol by as sort of the Stackelberg game setting in which the platform publicly commits to some strategy for revealing information, saying something like, if you don't reveal all facts about price, I will reveal these facts to the user. The seller then sees the user query and they reveal some set of facts based on this. And the platform then sees the query, the set of seller revealed facts, and then they reveal some other facts according to their fact revelation strategy. And then the user takes some action, which is presumably some function of all the facts that they know. And so, this is an informal version of a theorem, but what we can say is that when the platform's utility is aligned with the user's utility, so the platform is just like a social welfare maximizer, at least from the user's perspective, then at the Stackelberg equilibrium, the platform will commit to revealing all public facts that the seller does not already reveal. And then the seller will best respond by, one, revealing said public facts so that the platform doesn't have to, and then two, strategically revealing any private information that they may have. And like I said, this is ongoing work. I think that there are lots of interesting directions to go from here. One which we're excited about is sort of extending this to the multi-shot setting and looking at the dynamics which may arise. And so, in reality, sellers on these platforms are interacting with many users sort of sequentially. And, we're interested in how this sort of equilibrium changes when you have such a setting. In particular, we want to answer questions like, well, how could the seller strategize with this private information if the platform can update their model once they get new information? So, once I reveal some private information, it becomes public. How does this change the optimal strategy in this game? Another interesting question is, how does the dynamics affect user welfare? And then this is something which I didn't touch upon in the talk, but is interesting nonetheless, which is, how often do LLMs hallucinate in these sales settings? So again, we didn't explicitly measure this, but at least we found from the things we tried, they generally were not hallucinating, but looking at sort of hallucination and not telling the truth are another interesting directions here. So with that, I'd like to conclude. Thanks.